Hello, this is our last note of our exponential and logarithmic function unit. Today we'll be solving word problems. In chemistry, the pH, which is the measure of acidity or alkalinity of a substance, is based on a logarithmic scale. A log scale uses powers of 10 to compare numbers that vary greatly in size. For example, very small and very large concentrations of the hydrogen ion in a solution influence its classification as either a base or an acid. The relationship between the pH and hydrogen ion concentrations is given by the formula pH equals the negative of log times hydrogen ion, where H plus is the concentration of hydrogen ions in moles per liter. Okay, seems a little complicated, but the work is actually not so bad. So our formula of pH equals negative log H plus. Okay, calculate the pH if the concentration of hydrogen ions is 0.0001 moles per liter. Okay, so that will be in place of the H plus. So our pH is the negative log of 0.0001. Okay, the log of 0.0001 gives us an answer of -4, and the negative of -4 is +4. So the pH of this liquid is 4. The pH of lemon juice is 2. Calculate the hydrogen ion concentration. So now we know the pH number is 2. We have our formula here. And we're going to isolate the H plus. So first thing we do is divide by -1 to get rid of that negative sign. So -2 will be the log of H plus. And we know that the log base 10, we can get rid of that log by making 10 to the power -2 equals the H plus. And 10 to the power -2 is 1 over 100. So the hydrogen ion concentration is 0.01 moles per liter. Okay, last one for pH. If the hydrogen ion concentration is a measure of the strength of an acid, how much stronger is an acid with pH 1.6 than an acid with pH 2.5? Okay, so we have two things to work with. Work with the first one. 1.6 equals negative log of H plus. Negative 1.6 is the log of H plus. And to get rid of that log, we have 10 to the power -1.6 equals the first H plus. Okay, that works out to about 0.025119 and so on. We don't really need that. Let's move on to the second one now. So a pH of 2.5. All right, so 10 to the power -2.5 is the H plus in our second acid. So how much stronger? Well, that means we're going to divide the first one by the second one. So the strength will be 10 to the power -1.6 divided by 10 to the power negative 2.5. And we know through our division law with exponents, we are subtracting. So negative 1.6 minus negative 2.5 will give us 10 to the power 0.9, which is 7.9. So the acid with a pH of 1.6 is 7.9 times more acidic than the pH of 2.5. Okay, done with pH. Now we're going to look at earthquakes. The Richter magnitude scale uses logarithms to compare the intensity of earthquakes. An earthquake with magnitude 2 is actually 10 times more intense than an earthquake of magnitude 1. The difference between the magnitudes of the two earthquakes can determine the difference in intensity. If the average earthquake measures 4.5 on the Richter scale, how much more intense is an earthquake that measures 8? Okay, well, this is fairly simple. We're just going to set up our exponents. So we just see the Richter measure is just the exponent. Okay, so we have 10 to the power 8 over 10 to the power 4.5, which gives us 10 to the power 3.5, and that works out to be 3,162 times more intense. Okay, and blue jeans fade when washed due to the loss of blue dye from the fabric. If each washing removes about 2.2% of the original dye from the fabric, how many washings are required to give a pair of jeans a well-worn look? And we're going to say for a well-worn look, jeans should contain at most 30% of the original dye. Okay, so the formula that we're going to work with, so it starts at 100% when you buy the jeans. It is decreasing, so 1 minus 0.022, it's decreasing by 2.2%. And we're going to say the variable here, the exponent is W for washes. Okay, the goal is to get to 30%. So we have 30 is 100, 0.978 to the power W. Okay, we're going to divide by 100. So we get 0.3 equals 0.978 to the power W. And then we'll use logs here to find, oh, sorry, I changed color. To find our exponent, we have the log of 0.3 divided by the log of 0.978, which means it will take 54 washes for the jeans to have a well-worn look. Okay, thank you.